Okay, learning target 1 is function operations and domain. Remember that we talked about domain, and we said that if you are unsure about the domain, a lot of these domains are going to be all reals. So that basically just means that the graph goes to the left forever and it goes to the right forever, so it covers every single x value. The only time it's not all reals is if you have a fraction or a square root. Problem number 1 says find g of x of 1. Now the fact that it says g tells us that we have to work with the g problem. So the g problem is going to be 3, x turns to these parentheses, and then plus 1. Then inside those parentheses, we plug in the x plus 1. So we put x plus 1 in here, and then we simplify. So when we simplify, we basically have to follow sort of like PEMDAS. You put this x plus 1. And a lot of times it's just going to be distribute unless you have an exponent. So I'm going to distribute 3. 3 times x is 3x. 3 times 1 is 3. And then we drop down this 1. And then we just combine like terms. So if I combine like terms, the answer is going to be 3x plus 4. The like terms are plus 3 and plus 1. So there's my answer. State the domain, all reals. Now I'll go ahead and show you guys, if you're going to use interval notation, which we're going to learn later on, all real numbers is written like this, the fancy math way. So we'll go like this, negative infinity to infinity. Problem number 3 says find f minus g of x. So if we're going to do f minus g of x, you're going to have the f problem first, and then you're going to have the g problem second, and then you have to put a minus in between. So the f problem is going to be 6 minus x squared. What did I write? 6x squared. 6 minus x squared. And then the g of x problem is going to be 3x plus 1. Now this problem, it's got some numbers out in front that you can't really see. So we're going to put like an invisible 1 here and an invisible 1 here. And then we're going to use the distributive property. If I distribute a positive 1, this is 6 minus x squared. And if I distribute the minus 1, that's going to give me minus 3x minus 1. And then I just have to combine like terms. Now I'm going to start with the highest exponent. The highest exponent is negative x squared, and it doesn't have anything to combine with. So I'm just going to write that first because of standard form. Then after that, we have to put the x's, x to the first. So minus 3x is next because it can't combine with anything. And then finally, we're going to combine the 6 and the minus 1. So 6 minus 1 is positive 5. And then that's our final answer. State the domain again. If you want to just put all reals, that's okay. That means that the graph goes left forever and right forever. But if you want to write it the fancy way, it would be negative infinity to infinity. The next one says find f plus g of x. So almost like the last problem, we're going to kind of start it the same way, except in the middle, we're going to have a plus sign. So we're going to have 6 minus x squared, and then we're going to have 3x plus 1. Just like I mentioned before, there is an invisible 1 in the front. That's supposed to be a dotted line, by the way. Now, when you distribute a positive 1 to both of these, nothing really happens. So if I do a positive 1 like this is 6 minus x squared. If I do a positive 1 like this, that's going to be plus 3x plus 1. So it's almost like we just took the parentheses off. When we combine like terms, it's almost identical to the last problem. The negative x squared doesn't have anything to combine with. So we have negative x squared, and then we have the plus 3x. That can't combine with anything. And then we're going to combine the 6 and plus 1 this time. So 6 plus 1 is 7. That's our answer. And then state the domain again. That's going to be all reals because there are no fractions and no square roots. So we're going to put all reals here. And if you want to get fancy, you can always put negative infinity to infinity. That's how you write all reals, sort of using that notation. Okay, next problem says find f times, remember this black dot right here means times. So f times g. So we're going to go like this. We're going to put f here and g here. Put x squared minus 25, and then 4x minus 5. So we're going to basically FOIL. I'll try to use colors so you can follow along. So if I multiply these two together, that's going to give me 4x to the third. If I multiply these two together, that's going to give me negative 5x squared. And if I multiply these two together, that's going to give me negative 100. And if I multiply, well, 100x, almost forgot. And then if I multiply these two together, that's going to give me plus 125. Then we have to combine like terms. Usually on these types of problems, the like terms are right here in the middle, but it doesn't look like this has like terms. So that's actually the answer, and it's in order. When we put these in order, we have to do it by the exponent. So it goes x to the third, x squared, x, and then no x. So that's our final answer. Now we work out this. State the domain, there's no fractions and there's no radicals, so this is going to be all reals. And like I said a few times already, if you want to get fancy with it, interval notation, that's the math way of writing it, with negative infinity to infinity. Okay, next question says find f over g of x. These ones are my favorite because there's no work to do. I don't know why the word always does that, but we're going to stick f on top. F was x squared minus 25, and then g at the bottom was 4x minus 5. And you could put the parentheses here. You can leave them off on the division problem. It doesn't really matter. But I mentioned before, these are my favorite problems because you don't do anything. We haven't learned how to divide these yet, so we're not really going to worry about that. And then finally, state the domain. This is the one that has a problem. The domain only exists if there's, the domain is going to be all reals as long as there's no fraction involved. This one does have a fraction involved, so the way we do it is we take the bottom and set that equal to 0 to find the number that's not going to work for us. So if I set this equal to 0, I have to add 5 to both sides. And then we'll have 4x equals 5. And then we just divide by 4. So for the domain usually is going to be all reals, except in this case. We found that x is not allowed to be 5 over 4. So it's going to be all reals, except x cannot equal 5 over 4. Okay, learning target 2, composition of functions. So these are the ones where you just plug in the stuff, and it's usually like a 2-step. This one, you can see it has a number in it. So we're going to do this one starting by putting the 14 into the F problem. So the F problem, what I can do here is I can actually split this up if I want, but I'm going to just kind of do this one at a time. So I'm going to do the F problem first. So for the F problem is going to be 3 square root parentheses plus 2. So I'm going to stick in the 14, and then we can head over to the calculator, type in exactly how it looks. So it is 3 square root parentheses 14 plus 2. And the answer is 12. So this first answer is going to be 12. Now the next thing that we have to do is, according to the instructions, once we find the answer to f of 14, we have to plug that result into g. So g is going to be negative 1/2 parentheses squared plus 3, and then parentheses again. You have to keep in mind every x that's here has to turn into a parentheses, and then those parentheses have to be filled with the 12 that we found in the first part. So 12 goes here, 12 goes there, and now this becomes a basic calculator question. So I'm going to type in negative, oops, only one negative, fraction 1 over 2, go to the side, and then parentheses 12, and we're going to want to square that, and then add 3 times 12. Enter, and our final answer is going to be negative 36. This right here is the overall answer to the entire problem. Okay, next one says f of g of x. So this one's a little different because it looks like the g of x doesn't have a number in it. So that means what we're going to have to do here is we're going to have to put the whole problem into f. So since f is first and we don't have any numbers, we're going to write down the f first. So f is going to be parentheses squared minus 6. And then you can't see it, but g of x is over here. I'll just put it up here so it's not that confusing. So I'll put 5x plus 1. So I want to stick the g of x problem inside of the parentheses of the f of x problem. So this is going to be square root 5x plus 1. Now the cool thing about this problem is you actually, we talked about this 2 right here. You don't have to write it out twice if it has a square root, because the square root and the exponent are going to cancel each other. So we'll just have 5x plus 1 minus 6. Now if that square root wasn't there, we would have to write it twice and FOIL it out. Like I said, you can't do it if it's got the radical. You can just cross them out. Then we combine these two. So we'll have minus 5, and we have 5x here, and that's our answer. Okay, next question. Very similar. This time we want us to put g of x into f of x, which is pretty much the same question, except now g of x is this, and we're going to have to put it right here, or we're going to have to put it right here. So if there are no numbers, we're actually going to start off with this problem, and we're going to rewrite the entire thing with parentheses. Don't forget about that plus 2 at the end, and then we're going to stick in the 3x into every parentheses. Remember that when you have an exponent of 2, that means that there's 2 of them, so this is 3x and 3x. And then you've got your minus 5. And then you have plus 3x, we don't need those parentheses anymore, plus 2. So this last part that we have to do is we just have to multiply this all together. Now in the calculator, we can't type letters, so we're just going to type the numbers. So we'll put negative 5 times 3 times 3. So this is going to give us negative 45. X times x is x squared, and then you bring down the plus 3x, and you bring down the plus 2. So that would be our final answer. Okay, next one, find g of f of x. So pay close attention to your directions, because this time we're actually going to start off with g, and we're going to put f of x inside of it. So the g problem is going to start off being 20, and then parentheses, and then we're going to stick this stuff, the f problem, inside of g. So the x is gone because it turned to the parentheses, so we're going to put negative 5 over 4 x plus 2. Then we just use the distributive property. And again, that part right here can be done in the calculator if you just leave the x off. So we'll do 20 times negative fraction 5 over 4. 5 over 4. And then we'll just reattach the x once we get the answer. So the answer to that is negative 25. So we have negative 25x. And then we distribute this, so that gives us plus 4. That's our answer. Yeah, I kind of mentioned this in class. There's always going to be a problem on our test where someone did problems wrong, and we got to find where the mistakes are. So let me figure out first what the two problems were, and obviously the first thing you want to check is did they plug it in right. So in this problem, they're going to put the g of x inside of the f. So the g of x is this stuff, and it has to go inside of this f function. So I see the parentheses, I see the squared, and I see the plus 4. So that's absolutely correct. That the first step is done right. Now the part that we talked about in class though is a lot of people think that you can just distribute the 2, but you can't. Remember that when we have that 2 there, that 2 actually has to be written twice. So what they should have done is written 2x plus 5 and 2x plus 5, and you can't see that because Andy writing did. But the mistake is actually in here. They are missing a term that's supposed to go right here when you FOIL that out. So column A is definitely wrong. Next, we're going to check the other problems. So let me erase the marks that I made. Get rid of all this stuff. I like to write all over the equations so that way I can make sure I'm doing it right. So this time I want to put f inside of g. So the f problem is this one, and I'm going to have to put it right in here. So step 1, we're checking if they plugged it in right. There should be a 2, a big set of parentheses, and then a plus 5 at the end. And on the inside, we should have x squared plus 4. So that step is perfect. The next thing you have to do is you have to use the distributive property. So they multiply these two. So that part's good. And they multiply these two. There's your mistake. That is not correct right there. That should have been 8. So both of the problems are wrong. So we would pick C. Both column A and C are incorrect. Find the inverse relation. So the big thing about the inverse relation is you just have to switch your x and your y. And we understand, hopefully, that f of x is the same as y. So I'm going to start off there. Then I'm going to flip-flop the two letters. So x becomes the y, and y becomes the x. And then I copy everything else down. So there should be an equal sign of 12 minus 3, and then a squared on this. Now we have to solve for y. So if I solve for y, I'm going to subtract 12 from both sides. Be careful with x minus 12. Those are not like terms. So you can try x minus 12 equals minus 3y squared. And then we just divide the minus 3. So we're trying to get the y by itself. We divide the whole thing by minus 3. You can actually split up the x minus 12 divided by the minus 3 into two separate minus 3s, but I'm too lazy, so I'll just leave it. I break the board. So these will cross out. I'm going to let the board keep doing that. Cross these out. Okay, my board doesn't allow me to write, so I'm just going to write it like this. So we'll have y squared equals x minus 12 all over minus 3, and then we'll square root both sides. That's how you're going to do the little 2 up there. So our final answer is going to be y equals plus or minus, because that happens every time you square root something, x minus 12 over minus 3. And that would be our inverse. And to show it's the inverse, we'll put a little negative 1 up here. And you can change that back to f of x if you want. You can also write f inverse x. That also means the same thing. I don't really care though, because my thing is, can you get this part? That's what I want to know. Number 17, find the inverse again. So same steps. This is the y. Not sure what's going on with this thing. It keeps moving me. So this is the y. Somebody call a priest. Now, this is your y. And then we're going to have to switch the x and the y. So x goes here, y goes there. Everything else stays exactly the same. We have 4 over 5 and then plus 1. Then we have to solve for y. So I'm going to subtract 1. Subtract 1. This is x minus 1 equals 4 over 5y. And then I'm just going to get rid of the 4/5. There's an easy way to do it. You just have to multiply by the reciprocal. So you multiply by 5 over 4, and then you have to make sure to do it to the entire other side. So you've got to put it in parentheses. 5 over 4. I cancel that, I cancel that. So we end up with y equals. And you can distribute this if you want, but I'm just going to leave it for now. So it's 5 over 4x minus 1 in parentheses. So that's my answer. Okay, the big thing you have to know about inverses is that the x and y switches. So the x is the domain and the range is the y. So if they're asking you what happens to the domain and range of a function if you look at its inverse, well, it's easy. They should flip-flop. So this one should become the range and this one should become the domain. So your domain is going to go from 0 to infinity, and then your range is going to go from negative infinity to infinity. And again, that's happening because your x and y flips. The x is the domain and the range is the y, so then your domain and range should also flip. Okay, graph of a function. So if we have to find the graph of a function, we have to find the coordinates of the points. So let me make a table here for x, y. Starting with this point over here, that's going to be 1, 2, 3, 4, 5, 6, 7 to the left. And then 1, 2, 3, 4, 5, 6 down. And this is the next point I see. So that's 0 down to 4, I think. Yep. The next point is this one. That one's going to be at 1 to the right, and then 2 down. Next point is here. Now it looks like it's at 2, 0. And I think that's the last point. So to find the inverse, the x and the y, we just have to flip. So I'm going to flip them like this. And I'm not talking about the signs. I'm talking about literally flipping their position. So the x becomes the y and the y becomes the x. So we should be able to plot these points now. So if I go to negative 6, 1, 2, 3, 4, 5, 6, and negative 7, 1, 2, 3, 4, 5, 6. So it's kind of off the chart. That's okay. And we have negative 4, 0. 1, 2, 3, 4. Goes here. And then we'll have negative 2, positive 1. 1, 2 to the left, we have 1. And then we'll have 0, 2. So 0, 2. Now, some people have a hard time seeing these, so you have to also understand that there is a line of reflection that's happening here. The line of reflection is a perfect diagonal that goes like this. So you should get sort of like a mirror image on the other side of that line. So we're going to have some type of graph that kind of goes up here this way, comes like this, and then heads away. So that's the picture of the inverse. Last one is determine if there are inverses. Well, here's the thing. If I can just make a list of the points for the g of x and the f of x, then we can just compare them to see if they flipped. So starting with g of x, I'll put x y like this. I'll pick some points here. So it looks like, I don't know, it looks like this is a point. So that's at 0, 1. Let me pick another one. Here's another one right here. That's at positive 1, negative 1. Maybe one more. That's at 2 to the right and 3 down, so 2, negative 3. So if there are inverses, then if we flip those, those should be on the graph. So if I look at the graph, yeah, so I should have a point at, 1, 0. So if I go to 1, 0, that's right here. I should have a point at negative 1, 1. Negative 1, 1 is right here. And I should have a point at negative 3, 2. So 1, 2, 3 to the left, 1, 2. So that clearly is not. So they're not inverses. No. And that's pretty much all you have to know for this test.